doing this by voice or video, or what are you doing?
Yeah, it'll be a video.
Okay. All right, so since we're starting here in the boiler room, the domestic hot water system, which has gotten a lot of attention lately, and we'll show you the boilers, are controlled, the returns are controlled by these hot water pumps. And these things basically run themselves, but the control system turns them on and off. And once a week we rotate which one is the one that's running. And if we shut one off, in 30 seconds the other one will come on. So there's only one of each pair, so the 3A, 3B pair, one will be running at any given time. And again, we'll show you on the graphics. And then of the larger systems, the 2A, 2B, we've got the same arrangement. The domestic hot water itself is controlled, basically it's its own system, but we've got communication to all the domestic hot water boilers, which are over here, so we'll take a look at that. Behind this cover here, and I actually will be able to remove it, behind this cover here is a communication card that both boilers are, basically this is talking to this boiler is talking to that boiler, and anywhere you see these blue cables, this is our network. Okay. So all the BMS stuff is on this blue network, so we're talking to these two boilers. We don't do, we just give you a lot of information about their firing rate, their temperatures in and out of themselves, things like that. So it's just a lot of information just so you can, from downstairs, see what's going on.
Gotcha.
Right.
I have a quick question.
Certainly.
How often do they go out?
Those? I don't know. I've had some that have been running since the early 2000s that just haven't moved out. They're fairly robust because they don't have relays or inputs or outputs. All it's doing is just a little computer in there that's talking one language and converting it to another. It's a fairly simplistic, robust device. Yep. Good question on that. The other set of hot water boilers has a similar communication card sitting behind here. It's a little more involved to get to it, but it's a very similar card. So again, we talk to both of these boilers, hot water boilers, and off we go. Now we've talked this morning already about the fact that these two valves are in the domestic hot water system, and they're controlled by this temperature sensor here that's going to be relocated here hopefully by the end of the week. And so while all I do is communicate to the domestic hot water, I don't really control it. With the exception of these valves will start to swing water and kind of short circuit these tanks if the water gets too cold. All right, 300 showers happen all at once. All of a sudden our domestic hot water temperature dives. I'm going to swing the water so that it shortcuts the tanks and gets us back into the boilers as soon as possible. And then it'll trigger its way back. And that's the extent of the domestic hot water system. Okay. All right, let's head out to the condenser water system now that feeds the condenser water to all the fan coils in the rooms. My panels have their labels yet, but they're coming. They're going to be a black label with white engraved lettering on the top of every control panel. So we use the same brand everywhere. So if you see this color of controller, that's ours. Well, all right. So most of the controllers that we use are by Johnson Controls. These PCG controllers. The beauty is that the software that I use can actually route its way through the supervisory controller. So I can be remote and reprogram this if I have to. I don't have to be plugged in directly into the controller here to handle that. So we will see this panel on the plans, and I think you already emailed the latest set of plans that show that. They are going to all look like this, and these ones are marked up with just notes that the installer was taking as to what color went where. But all the plans will look like this. start with a flow diagram of the piping. And again, this is schematic in nature, so it's not going to exactly match what you see on the field, but you'll see the same amount of equipment, right? The two cooling towers, the two pumps, boiler, fans, so on and so forth. So this system here, I don't know if the mechanical contractor is on there in service with you yet on how this system is working.
Nope.
No? Okay.
I'll tell you that right now.
I'm going to just give you a kind of an overview.
Thank you.
All right, so the temperature of the water that goes down and feeds all the rooms, all those heat pumps in those rooms, is controlled between 60 and 80 degree water.
Okay.
All right, and it sounds like a big swing, but in terms of water, it's not that big of a swing, and those heat pumps can handle that. They just need some place to discharge the heat off of their
Right.
compressor. So, and that's what they're for, right? It's just to cool that compressor that's in each unit. So there's two cooling towers that cool the water down to 80, and if it continues to drop, then there's two boilers that bring it back up to 60. Right now, the two boilers are right here, boilers 3 and 4. Unfortunately, boiler 4 right now is
Inoperable.
inoperable, it's under some repair, but boiler 3 is still doing its job. And it's taking the water that's coming back from the rooms and making sure that it doesn't drop too cold. Now, as it turns out, I don't actually want to turn this boiler on until it gets below 60, but the boiler itself right now has a low limit of 70.
Okay.
So it's kind of idling itself along at 70 degrees. And so we're going to work with the mechanical contractor and get that resolved so that this thing will actually go lower and allow me to control how low that water is controlled. So in reality, the water going down to the basement, or to the rooms, is between 70 and 80 at this point. It's allowed to go wider, but this thing says, no, I don't want it to go any closer than 70. So we're going to work on getting that fixed.
All right.
The cooling towers. The cooling towers themselves, I actually don't do a whole lot of control on. I simply say if the water coming back from the building, and that's actually the pipes you're standing on right there, if that water is too hot, if it exceeds 80, I turn on the cooling towers. Now there's two sets of cooling towers,
Right.
but they run by their own set point here.
Okay.
So when
Which
they,
end do we know set point on?
I believe right now it's dialed into 85, but we'll take a look. Oh, you know what? The thing is, I don't have these turned on right now, so they're not lit up. This is also a little thing we're working out with the mechanical contractor. I'm supposed to have temperature control of these, but this is all kind of a built-in system. So right now, if it gets too hot, I turn on the water or turn on the cooling towers, and these controls here turn on the pump that pushes water over the media and speeds up and slows down the fans that are in there as well.
Right. Question. Now, because you don't have to control those things right now, how does this know when to turn on?
This is actually enabled by me, by my system, reading the temperature sensor below your feet. I can tell that the water's getting too warm, and I say, give me a cooling tower. Then I turn this on, and then it runs by itself. If I need more, I then turn on the second one, and
So
it runs by
technically-
itself.
Technically, you have control.
Well, just on and off.
Oh.
I don't actually have the ability to say, now that you're turned on, I want you at 82 degrees. I don't have that ability. It's all dialed in locally here.
Which is not right now, right?
Right. Well, it's not turned on right now because I don't need the cooling tower
Gotcha.
on. It's cool enough outside. The water coming back is not hot, and so. But that's ultimately what's going to happen is as the day warms up or as we get into the warmer months, that water coming back is going to be hot, and these cooling towers will turn on.
Gotcha.
We are measuring the water flow that flows into. As the towers operate, they're blowing a lot of hot water that's evaporating out the top. And so the water that's making up the system is measured by this flow meter right here. So we measure how much water is flowing through this pipe,
Right?
and heading to keep the towers full,
Okay.
right? So that you know the system is open only when water is dropping through the cooling towers.
Can it be turned on manually?
Can the cooling towers be turned on
Yes.
manually? My understanding is that these factory controls will.
Okay.
There is a so you can bypass the fans, but I don't see that turned on. And the pump right now is in auto. Yeah, it appears as though if my system is not telling the unit to turn on, it won't turn on.
Gotcha.
Once it's turned on, then you have ability to say, hey, I've turned on my cooling tower, but my fans are just loping along.
So
I
when
can-
would that be operational?
What's that?
When would that be operational?
When the water gets above 80. Yep.
All right.
All right, that's the fun stuff here on the roof, the boilers and the cooling towers and the associated pumps. The two big pumps that are pushing that water through these big
Right.
pipes, those are those two pumps right there, and they're controlled by drives here.
Okay.
I do control those two big pumps. There is a pressure sensor, and we'll show that later. It's in the garage. And so the water pressure from the supply to the return, I control those pumps to make sure there's plenty of water all the way down on the second floor to make sure that all the heat pumps between the roof and the second floor
Gotcha.
have plenty of pressure water to
Gotcha.
operate.
Gotcha.
Yep. So these pumps are under my control. We do turn them on and off in turn, and if one fails, the other one picks up. Yep. All right. Scattered across this roof and the upper roof are all sorts of exhaust fans and so exhaust fans, supply fans, makeup air units. There are 3 fans. Well, actually, there's more than that. There's a handful of fans that are controlled by the fire alarm system. We don't control
Right,
them,
right.
but we simply monitor them. So you will see that we're building a table of all the fans, and so you'll see at any given time what's actually running versus what's been shut off. A fan being off is not necessarily a bad thing. Some of the stairwell pressurization fans don't need to turn on unless there's a fire,
Right.
and then it pressurizes the floor.
Okay.
So, but you'll have a table showing you the on-off status of everything and the control status. All right. I think that's all there is to see on this roof. Set up this. Try not to let that close.
Oh yeah,
You remember this?
I already remember that.
Yeah.
Oh yeah.
So this is kitchen exhaust fan,
Absolutely.
roof deck 1. This is the main exhaust fan for the hoods for the study hall lounge kitchen, right? So I do have speed control on this. It doesn't modulate, but I can simply tell it, hey, I want you to run at 100%, I want you to run at 75%.
Right.
So our control system detects when the button has been pressed down in the kitchen to say, we need exhaust fan. Once I tell that button has been pressed, I then send a command to turn this kitchen fan on, and then it will operate at the speed that I tell it to. So again, very familiar. It's got these drives. Have you seen inside these drives? Okay. So again, any of the drives that have a blue wire going in and out of them, we're communicating to, and I can tell you, is it running? How fast is it running? How much power is it drawing? All this and the other.
Gotcha.
Okay, great.
No better.
There are a couple locations up here where the exhaust or supply fans are turned on or off or simply monitored for status. And so you'll see up here, here's the control relay for exhaust fan 12-6. or 12-7, 12.8, 12.9, 13.2, 14.1, so on and so forth. And so what we're looking for to make sure everything is copacetic is that this little light is twittering. That means that I'm communicating to it, and this red light indicates that we've turned the fan on.
Gotcha.
So as you look over here, you'll see red lights and green lights all the way down the board. That's what we want. So this is one location where we have those. The other location is right here. Yet more of these. Now, there are a couple locations. This is a temperature sensor that's measuring the temperature in here, and if it gets too hot, then it turns on the fan that serves this electrical room. But again, we've got these. So you'll see like SPF 1, SPF 3. SPF 3 is one of the stairwell pressurization fans. We don't turn that on. Fire alarm turns that on. But this is the module that we use to measure whether it's running or not.
Gotcha.
And so, but then more exhaust fans. And you'll see a table that we're building that has, to you, EF12.2 doesn't mean anything. You need to know what area of the building does it serve. So we're building a table that lists that all out as well. Because, yeah, if somebody says, I mean, supply fan 16.1 doesn't mean anything to you. But you just need to know what area does it serve. Exactly. Well, and by that way, you can also say, oh, this portion of the building seems to be stuffy, or these corridors seem to be, then you could look and say, all right, what equipment serves that particular floor?
Gotcha.
Yep, so we've got that. All right.
Nice key.
Okay, so 6 panels, all identical. They run the makeup air unit RD1 through 6. And before we're out of here, we'll have an engraved label to show which one is which. These not only run the makeup air units that serve the various floors, right, various side portions of the floors, but many of the miscellaneous exhaust fan statuses are also run into here as well. So these serve a dual purpose of controlling a piece of equipment and also reading some miscellaneous statuses. So again, this one, right, so here's makeup air unit 4, right, 1, 2, 3, 4, 5, 6. And this is number 4, but this one has an exhaust fan RD6 wired to it. So you'll see that reflected in the traffic as well. Yep. But not a lot that you're going to be doing with any of these kind of equipment, but again, I can remotely get into any one of these if something needs to be reprogrammed, added, changed, or whatever. Yep. All right, I'm going to want to put that on pause. Our next step is up the ladder.